So today we are going to study electrochemistry. And in this topic, what are the concepts we are going to study? Before giving answer to this question, I'm going to ask you one question. What do you have studied in thermochemistry? Because the word is nearly synonymous to this thermochemistry and electrochemistry. Anybody, what you have studied in the kind of the topic thermochemistry? Anybody, unmute your mic. Go to give answer in thermochemistry. What you have studied? No answer. Thermochemistry deals with the heat involved in a chemical reaction. Thermal energy. Chemistry, chemical reaction. And in thermochemistry, we are dealing with the two types of reactions. One is called heat releasing process, and the another is the heat consuming process. That's different. And from this, you renamed the reactions as spontaneous reactions. What is spontaneous reaction? The reactions are automatically taking place. In the automatically taking place, heat is released. And another we call it as the non-spontaneous reaction. The non-spontaneous reaction is one in which the reaction would not be immediately taking place. If you give assistance from outside, which assistant you are going to give? That in thermochemistry you are going to give the thermal energy. Therefore, such reactions are also called heat consumable or heat consuming energy. There is another type of reaction, we call it as the equilibrium reaction, in which the delta G is equal to 0. Here the delta H we represent the change in the heat content as enthalpy as negative, and the heat consuming process as the positive. And for the equilibrium, for some of the reactions, it may be delta H is equal to 0. But we won't take this as a criterion. We will take only the free energy change as a criterion for the spontaneity of the reaction. You have studied in thermochemistry. And then you are studying about you are giving various definition, the heat of formation, heat of sublimation, heat of neutralization, heat of oxidation, etc. Then developed the SS law of heat of summation. And you have studied many more concepts under this type of chemistry. So is the case with the electrochemistry. From the name itself, in thermochemistry, during the spontaneous process, heat is released. That is, system is doing work on the surrounding. It is released. It is consumed means the work is done on the system. Thermodynamics, you might have studied it. So is the case in the electrochemistry, but instead of thermo, here we are introducing electro. Thermo means thermal energy. Here electro means electrical energy. That is, now you have, you know, what are the concepts we are going to study under the topic electrochemistry. Due to some reactions, electricity may be produced. In which cases it is produced in spontaneous reaction, electricity is produced. That is, system is doing work on the surrounding. Just like in thermochemistry, electricity is produced. And the heat is produced, where electricity is produced. In a spontaneous process, electricity is consumed. Electricity is consumed. And in equilibrium reaction, electricity, there is no electricity at all, it is zero. Here the electricity is represented by E, the capital letter of the epsilon Greek letter. Small letter is the epsilon, and E, it is a Greek letter. E equivalent is the capital letter. E, it is equivalent to English alphabet E. We use this for the voltage of the cell, and we use this epsilon for the electrode potential of an electrode. But in some books, in alternatively, they would change according to their trend, but this is a normal consumption. Electricity is produced means here E is positive. Note the difference between this thermochemistry. Heat is released, delta H is negative. But in electrochemistry, spontaneous reactions are producing electricity. Here E is positive. In a non-spontaneous process, E is equal to negative. In equilibrium process, E is equal to 0. Therefore, under electrochemistry, we are going to study once again two types of process, spontaneous process and non-spontaneous process. Or in other words, spontaneous process, electricity is produced, that is, we are going to study voltaic cell. Voltaic cell means is an apparatus from which voltage is produced, electricity is produced. I mean, which time the electricity would be produced during the spontaneous process. And another cell, the reverse of this spontaneous process, we call the non-spontaneous process, in which we are supplying energy, electrical energy from outside, passing electricity through the solution and make the reaction to be taking place. Such cells are called electrolytic cells. The electricity produced cells are called voltaic cells. And by passing electricity, if you bring about the chemical reaction, we call it as the electrolytic cell. Therefore, under electrochemistry, what are the topics you are going to study today? One is the voltaic cell. Now we will give what are topics to be studied, and is the electricity spontaneous under spontaneous process. Voltaic cells. The voltaic cells are going to study the releasing of the electricity. And under this, we are going to study the electrode potentials. Electrode potentials. Or the electrode potentials, then applications of the electrode potentials. Using this, what are the problems we can work out towards this CSAR examination or other competitive examinations? Applications of this electrode potential. Under the applications electrode potential, you are going to see the construction of the shells. Then we are going to study the EMF diagram. EMF diagrams. Then after the EMF diagrams, we are going to study what is the concentration cells. Cell means here electricity is produced. Why we call this a concentration cell? Already voltaic cell is there. Instead of this voltaic cell, we are using concentration cell. What's the difference? Here also voltaic cell, also electricity is produced. In concentration cells, also electricity is produced. Then what is the difference? What is the necessity giving to under two different topics? We will see shortly. Then under this important application is the potentiometric titrations. Potentiometric titrations. Then the fuel cells and batteries. Fuel cells and batteries. With this, we have to, we will close these topics under spontaneous reaction types. Under non-spontaneous reaction, electrochemical reaction, we call it as a electrochemical reaction. Under non-spontaneous reaction, what happens? We are passing electricity through a cell to bring about the reaction, and such cells are called electrolytic cell. And this electrolytic cell, we are going to study by passing the electricity, how the electricities are conducted by the ions We call it as the conductivity of ions. After studying this, we are going to study ionic mobility. What is the difference between ionic mobility and the speed of an ion? We're going to study under this very quickly. And then application where non-spontaneous processes, conductometry, conductometry titration, or conductometry in simple because it's a conductometry. If you cover all these four topics in this, you will finish this non-spontaneous chemical reactions. In addition to these two, by applying these, various types of topics are there under the heading electroanalytical methods. Electroanalytical methods. What are the electroanalytical methods? Here, in which some of them from which energy electricity is produced, or we will supply energy, both are combined. And what are the topics to be covered under this potentiometric titration? Potentiometric titration or potentiometry, simply. We will see this application during our study under the spontaneous process. pH metry, then high frequency titration, then conductometry. This application we will see under the non-spontaneous of the reaction, conductometry. Then voltammetry, double M. And this one is comprising, this voltammetry comprising a group of electroanalytical methods. What are these different voltammetries? Anodic stripping voltammetry, cyclic voltammetry, then amperometry. This you have to study under this one. Next application is the chronopotentiometry. Then next is called the fluorography. There are two types, AC and DC fluorography. Under this fluorography also nearly four types of fluorographies are there. One is called pulse fluorography. And second type is the rapid scan fluorography. And next is sinusoidal AC fluorography. Sinusoidal curve you studied. Soidal AC fluorography. Then last, stripping analysis. And these are the applications of this electrochemistry under various analytical techniques. And if you studied this, you have completed electrochemistry. But presently, for the CSAR examination, I am going to discuss only these two topics, that is the spontaneous electrochemical reactions and non-spontaneous electrochemical reactions. Nearly Here also some 6 topics and here 4 topics and 10 topics we will cover. That is sufficient to appear for this CSAR examination if question arises in the electrochemistry. And with this short introduction, we will enter into the electrochemistry, the electrochemical reaction. Electrochemical reaction means where only one type of reactions will be taking place. What are the only one type of reactions? Redox reaction is going to be taking place in which reactions are going to taking place in the electrochemistry, whether it is a spontaneous process or a non-spontaneous process. No other reactions would produce electricity or no other reaction would consume electricity, only redox reaction. Well, because only in the redox reaction, electrons are said to be transferred from one species and another species. If you notice that movement of electron by some means, you can realize the movement of electricity. Therefore, the movement of electron is necessary. If you force the electron to transfer from one species to another species, that is a non-spontaneous process for which you have to supply energy. If the electron transfer is automatically taking place without any assistance from outside, it is a spontaneous reaction. And such reactions are responsible for producing electricity. During this course, both the reactions, electrons are said to be traveling. And therefore, in electrochemistry, throughout the electrochemistry, we are going to see only the redox reactions. In this redox reaction, you will be always coming across which species is undergoing oxidation, which species is undergoing reduction, and how many electrons are involved in the process, because some problems involve the number of electrons, and the number of electrons involved in the process will not be given to you. You have to find out how many electrons are involved in this process. Therefore, to acquainted with these problems, first you should have a knowledge about balancing the electrochemical reactions. Electrochemical reaction is nothing but the redox reaction. I think all of you have studied how to balance a given redox reaction very easily. Or before seeing this balancing this electrochemical reactions, you should know what is the oxidation state of a given species, how to identify the oxidation number of a species by using a set of rules. I think all might be well familiar with finding out the oxidation number. Before seeing whether you are well acquainted with this following reaction. Giving the electrochemical reaction, cadmium in the solid state plus nickel oxide in the solid state plus 2 water in the liquid state, giving cadmium hydroxide in the solid state plus NiOH2 solid state. This is the net electrochemical reaction taking place in the nickel cadmium battery that we call as the NiCad. This is the net reaction taking place in the nickel cadmium battery, or it is generally called as the NiCad battery. We call it as the NiCad battery. Here this is a NiCad battery given. Now my question is, which species is undergoing oxidation? Which species is undergoing reduction? How many electrons are involving in this net reaction? This question, if you answer this, then now you are well acquainted with identifying the oxidizing species and reducing species, because one of the applications of electrode potential is to find out which is a strong oxidizing agent, which is a strong reducing agent. Which species would oxidize which species would reduce which species. This type of questions may be asked, or it will be asked, or it will be already asked, for which you should be well acquainted in calculating the oxidation number of any given species. Now, which is undergoing oxidation, for which first we will start with step by step, then we go by jumping the process. Where if you are well familiar with this, seeing the equation, you will be saying that this is the oxidizing species, this is the reducing species. Definitely, any element in their state, solid, it's a neutral state. Here, the oxidation state of the element is zero. If it in a compound form CdOH twice, definitely it will be undergoing oxidation or reduction. And how to find out the oxidation state, for which you should know the oxidation state of the other species present along with it. What is the oxidation state of cadmium in cadmium hydroxide, for which cadmium let us having it is the X. And in the oxidation you know the rule, it is always having -2, except in two conditions. That is in peroxide is -1, and in fluorine monoxide it is +2. It is +2. All other things it is -2, therefore it is -2. Hydrogen is +1, therefore total charge over it is -1, and 2 minus equal to 0, net charge over the 0, therefore cadmium is +2. Therefore here cadmium is +2. Cadmium in the reactant side 0, in the product side it is +2. Therefore, which species is undergoing oxidation? Cadmium is undergoing oxidation. If cadmium is undergoing oxidation, the other reactant, the nearby reactant, you can easily say it should be undergoing reduction. From which oxidation state to which oxidation state? That is essential. Here, what is the oxidation state of nickel? If you apply the same principle, the oxidation number of this nickel, you can immediately tell it is 4. And in the product side, what is the oxidation? It is the oxidizing agent. I'm sorry, it is a undergoing oxidation of a nearby species, definitely undergoing a reduction. If it is a reduction, oxidation number should be decreased, and here OH is met is -1 and 2 minus, and therefore it is 2. Therefore, what is the change in the oxidation state of the nickel? From +4 to +2. How many electrons are involved? 2 electrons are involved. The same number of electrons should be involved in the cadmium. Cadmium is undergoing oxidation. 0 to +2, 2 electrons. Therefore, net 2 electrons involved in this redox reaction is 2. If it is a spontaneous reaction, electricity is produced. If it is a non-spontaneous, you can make the reaction to be taking place by passing electricity. That is the basic principle of this electrochemistry. Therefore, if you are able to identify this, because in some of the formula you are going to calculate N, they would give you only the net reaction, they won't give the number of electrons involved. Because only in the half reaction you can see the electrons. In a net reaction, you can't see the electrons either in the reactant side or in the product side. Therefore, first you should be able to calculate this. Therefore, I think you are calculating the oxidation state. And now we are going to see, or you can easily give one answer for the following net reaction. I will move to the next type of this aluminum solid plus MnO4 minus aqueous giving AlOH4 minus MnO2 solid. It's a reaction. Here is a balanced reaction. Which species is undergoing oxidation? Which species is undergoing reduction? What is the change in the oxidation state? How many electrons are involved in the native process? We can take only one thing that is sufficient to give how many electrons are undergoing in this process. Take, if in the solid one element is present, take inside the element is having zero oxidation state, immediately come to the product side. AlOH 4 times is there, minus is there. What is the oxidation number of this? X. And how many OHs are there? 4 OH. Therefore, one OH is having 1 minus, 4 OH and 4 minus, and equal to the oxidation number change is equal to the charge over it, equal to -1. X is equal to 3. Therefore, aluminum is undergoing oxidation. Then definitely manganese would be undergoing reduction. How much valence oxidation difference? Definitely these three difference would be there. Okay. Then now total number of electrons involved in the process, 3. Because the 3 electrons here it is getting electron released by the aluminium. That 3 electrons will be consumed by the manganese. You can check it. In the manganese, what would be the oxidation state of manganese in permanganate? +7. And here manganese dioxide +4. Here the change in the one is +3. And here you may be asking one question. Which species is oxidizing? Which species is reducing? Oxidation means, you know what is the oxidation. Oxidation means losing the electron is called the oxidation. Here aluminum is losing the electron, therefore it undergoes oxidation. Which is called reduction. Accepting electron is called reduction. You can having one mnemonic for this, Leo or Leo is the line, we call this a line. L for losing, E for electron, O for oxidation, Leo. Then another is Ger. What is Ger? Gaining electron is called the reduction. Leo, the line says Ger அப்படின்னு சொல்லுவோம். Leo oxidation reduction, you can easily say this. Therefore, aluminum is called, because it is producing electron, aluminum is called a reducing agent. Which one produces the electron is called the reducing agent. Which one is accepting the electron? Here, permanganate is accepting agent. Therefore, permanganate is called the oxidizing agent. Oxidant or oxidizing agent. Aluminum is called the reducing agent. Generally, all metals would be having reducing character, which we are going to see the application of the electrode potential. In this way, you should be able to identify which is an oxidizing agent, which is a reducing agent, how many electrons are involved in the process. If you work out repeatedly, do the exercise, definitely you will be well versed in this electrochemistry. Looking at the equation itself, you are able to guess out the total number of electrons involved in the process. Therefore, with this, we will go to the next step, balancing given electrochemical reaction. If it is an unbalanced state, you are asked to calculate what would be the balanced oxidation state, for which I am going to give you the in a CSAR problem like this. Take down the problem. If you complete and balance the following equation in acidic solution, I will go to write down the equation. Take down the equation. How many water molecules, continue the problem, how many water molecules are there in the balanced equation? Are there in the balanced equation? A, 4 on reactant side. 4 on reactant side. B, 3 on product side. C, 1 on reactant side. D, 7 on product side. E, 2 on product side. 2 on product side. Then how to balance these equations, a redox reaction, for which we are having one technique called half reaction method, balancing the redox reaction and half reaction method. Generally, this procedure will be followed for following the redox reaction. Here in this half balancing reaction method, you have to separate two half reactions. What are the reactions taking place in the redox reactions? What is the basic reaction that are taking place? Redox reaction, the name itself indicates a reduction reaction takes place simultaneously, an oxidation reaction takes place. Therefore, it is separated into two half reaction means, and one half reaction is the oxidation half reaction, and another we call it as the reduction half reaction. Therefore, divide the equation into first oxidation half reaction and reduction half reaction. Therefore, here we will divide this one as Mn 2 plus. Take this one, aqueous. And what is the species present in the other side? MnO4. That is sufficient. This species is undergoing oxidation or reduction, whatever may be the case, we will see it. Similarly, another thing we are going to see, the next one is sodium bismuthate. Solid, giving bismuth 3 plus aqueous plus sodium aqueous. This is the second half. We have broken the given equation, unbalanced equation, into two halves. Here now balance. Next step is balance each half of the reaction. You have to balance this half and this half. And for this, first balance the elements other than hydrogen and oxygen present. Balance the elements other than hydrogen. Here manganese present, here also manganese present. First balance that. Here one species, there also one species. Therefore, one is already present. Okay, over this over. Then next second step is balance oxygen atom if present by adding. Here, the first equation, 4 oxygen atoms are present in the product side, no oxygen on the reactant side. Balance the oxygen atom in terms of water. The oxygen should be balanced in terms of water with the required number of oxygen. Here 4 oxygen is there. It should be balanced in this side with the water with the required number 4 oxygen. Therefore, you should balance with the 4H2O. Then finally balance the hydrogen atom by adding H plus ion. If oxygen is to be balanced, balance the oxygen atom by adding in terms of water molecule. Finally balance the hydrogen. If hydrogen to be balanced, if some difference is there, the difference should be given in terms of H plus. Here in the product reactant side, 8 hydrogen are there. No hydrogen is present in the reactant product side. Therefore, balance the hydrogen by adding required number of H plus ion. The base is better than hydrogen and oxygen. Second step, balance the number of oxygen in terms of water. The water should be added to the appropriate side. Third thing is the balance of hydrogen atoms by adding required number of H plus to the appropriate side. And fourth step is the balance the charge by adding a required number of balance the charge by adding a required by adding in terms of electron as needed. How many electrons are needed? And the net charge here it is plus 2. In the product side, 1 minus and 8 plus are there. Therefore, the net here 7 plus. Here in this side, 5 is 2 plus. Therefore, the 7 plus should be converted into 2 plus. Higher positive charge should be converted into the lower charge by adding appropriate number of the electron. Here, the 5 positive charge should be 7 positive charge should be decreased to 2 positive charge by adding 5 electrons on the product side. After adding this product side, now the charge balance in both sides is plus 2. Now we have balance the one half reaction. And whether it is these half reactions are oxidation half reaction or reduction half reaction, you can easily tell this. If electrons are found in the product side, it is an oxidation half reaction. If the electron is seen in the reactant side, it is a reduction reaction. Therefore, now we have balanced the oxidation half reaction. Similarly, now you have to balance the reduction half reaction. Which would be the reduction half reaction? The other half reaction. It would be present. It would be definitely a reduction half reaction. And now we are going to see the reduction half reaction. And which should be balanced with sodium bismuthate. Sodium bismuthate, BiO3, solid, giving Bi 3 plus aqueous plus Na plus aqueous. This is the given. Now we are going to balance this half reaction. First step is balance the species present on either side, other than oxygen and hydrogen. Here, sodium, one sodium here, here also one sodium balance, one bismuth here, one bismuth here balance. Then we have finished the other than oxygen hydrogen species have been finished. Next, we have to balance the oxygen by adding required number of water on record side. Which side we should add 3 water molecules. 3 water molecules. In which side? In the product side, 3 water molecules. Liquid. Okay. Three water molecules, liquid. Then balance, which should be balanced hydrogen. The hydrogen in the side, no hydrogen is there. There, 6 in the product side, 6 hydrogens are there, for which you have to enter 6 H plus ion in the product side, reactant side. The last is balance the charge. Here plus 6, here plus 3, plus 1 is there. Therefore, you have to, here plus 6 is there and plus 4 is there. You have to decrease the higher positive charge to the lower positive by adding electron to the appropriate side. Here, how many electrons should be added? 2 electrons should be added in the reactant side. Now we have balanced it. Once again, check whether we have correctly balanced or not. Check it. Now we had another half reaction. One half reaction, the above you call it as the oxidation half reaction. The below is a reduction half reaction. How would you identify it is an oxidation half reaction? two things. One, the electron is appearing in the product side is an oxidative reaction. If it is appearing in the reactant side, it's a reductive reaction. Manganese is in the +2 state. Here, manganese is in the +0 state. Therefore, definitely the reaction is an oxidation. That is increasing in the number in the positive direction is called the oxidation. Here, bismuth +5 oxidation number, and here only +3, decreasing the oxidation number in the positive direction. It called as the reduction. That can also be used to find out whether it's oxidative half reaction and reductive half reaction. Now we are balancing that two half reaction. Next step is the total net reactions to be balanced. For net reactions to be balanced, no electron should be involved in either in the reactant side or in the product side, because the electron produced during the oxidation reaction would be totally consumed by the production half reaction. Therefore, no electron should be present on either side. In the oxidation step, that is in the first reaction, we are having 5 electrons. In the reduction step, that is in the second step, we are having 2 electrons. These two are not equal to each other. This should be made to equal to each other, for which you have to multiply equation 1 by 2, that is oxidation reaction, by the electrons present in the reductive. And the sum of the reaction 2 after multiplying with the electron 5. And after multiplication, and you are getting 2, first add this one, multiply this 2Mn2 plus aqueous plus 6 water liquid plus, we will have a gap. In this gap you are going to write down the next second reaction, giving MnO4 minus aqueous plus 8Hu plus 10 electron.
Sir?
Yeah.
2Mn2 plus போட்டுக்கோங்க சார். அதுக்கப்புறம் 6H2O போட்டுக்கோங்க சார்.
Sorry. You have to multiply 8H2O, 2MnO4, 16H plus. Sorry. Thank you very much. 16H plus and so on. Okay. Do you now follow this? Shall we move to the next one? Now, you have to add by the second reaction by multiplying with 5. If you add this 10 electron plus 5 into this 30Hu plus 5 into this 5 NaBiO3 solid. Okay, giving 5 Bi3 plus aqueous plus 5 Na plus aqueous plus 15 H2O liquid. Okay, now you are going to add this one, 10 electron and 10 electron gets cancelled. Here during this addition, if same species are present on both sides, it should be cancelled accordingly, and the remaining number should be placed in the appropriate side. In our problem, it is asked how many water molecules are there in the balanced equation. They are asking only the water molecules. Therefore, take the water molecules around 8 water on the reactant side and 15 water molecule on the product side. If you cancel this, and how many water molecules would be left on which side? Tell me. Anybody? How many water molecules?
7 water molecules in the product side.
In the product side. The question may be like this, or I will now change the question. how many H plus ion would be present? So many H plus ion on reactant side, so many H plus ion on the product side. You can put 4 answers would be given. What would be your answer if it is, the question is in terms of H plus ion, how many H plus ions would be present on which side?
14 H plus
14 H plus ion
14
on which
Reactant.
side?
reactant.
And so on. This is the methodology by which you can easily find out. And this reaction is carried out in acidic medium. Therefore, definitely H plus ion would be present either as a reactant or as a product. This is the methodology by which you can find out this type of question. We normally call it as it's a basic type of question. It is a substandard for CSAR. Generally not asked in the CSAR examination. It may be asked for the NEET examination or JAM examination, and not for this, but this is the basic principle. And take down a question and find out your answer for the next one. Balance the following equation. In acidic solution, if you are given acidic solution, definitely H plus ion would be appearing, most probably in reactant side, or in some cases it may be observed in the product side also. Definitely it should be there. This is the question, unbalanced equation. You can answer this. And the question is, how many water molecules would be present in the net reaction on which side? First question. Second question is, how many H plus ions would be present in the net reaction on which side? You balance these accordingly. Okay. This is for an exercise for balancing an acidic medium. Sometimes the redox reactions may be taking place in the alkaline medium also. If it is asked in an alkaline medium, how to balance these? We will work out one example. Then I will give you one exercise. Do the exercise. Well acquainted with this. Okay, take down this. How to balance the redox reaction in alkaline medium. Question, and take down the question. We will give them in terms of the questions, and then we will work out this. If you balance the following redox reaction in basic medium, NO2 minus aqueous plus aluminium solid giving NH3 aqueous plus AlOH 4 times minus aluminate aqueous. How many OH groups are there? In the balanced equation? Option A, 1 on the reactant side. Next B answer என்ன சொல்லலாம்? 1 on the product side. C, 4 on the reactant side. D, 7 on the product side. Okay, now we are going to proceed. How to proceed this one? We will once again split into 2. The oxidation of reaction and reduction of reaction. What you have adopted in balancing the redox reaction in acidic medium, follow that same procedure up to the net reaction. It is no change in the procedure. But now you are getting a reaction which is taking place in the acidic medium. After that, there is a one step, you should convert it to a basic, that's all. Therefore, no other method is there. Therefore, balance this up to the acidic reaction, acid medium reaction. Why you proceed? For which we have to take NO2 minus giving NH3. This is a species undergoing either oxidation or reduction. And another half reaction is aluminium giving AlOH4 minus aqueous. The another species. Now what is the, now balance this, nitrogen is 1, ammonia is also 1. Now we have balanced the species other than oxygen hydrogen. Next step, balance the oxygen in terms of water adding to the appropriate site. Here 2 oxygen is present in the reactant site, but no oxygen is present in the product side. Therefore, you are adding 2 water molecules in the product side. Now we are going to balance the hydrogen. Hydrogen, total number of hydrogen present in the reactant product side is 7, and no hydrogen is present on the reactant side. Therefore, now we are going to add 7 H plus in the reactant side. The last step is to balance the charge. In the product, the balance is, the charge is net is 0, but here 7 plus and 1 minus is there. Therefore, now you have to balance how many electron on which side. That is, in the reactant side, 6 plus are there, but in the products, no charge is there. Therefore, now you are going to add 6 electron in the reactant side. Therefore, in the reactant side, the electrons are present. Therefore, we have balanced the reductant half reaction. Do you follow this? Reductive half reaction. And we are going to balance this oxidation. This is definitely oxidation half reaction. Aluminium here, OH4, 4 OH4s are in there. We are going to balance 1 aluminium and 1 aluminium and 4 oxygen. The 4 oxygen is added in terms of water in the reactant side. Then how many hydrogens are there? Here 4 hydrogens are there, here 8 hydrogen. Therefore, here the other side 4 H plus should be added. And now finally balance the charge. If you balance the charge here, AlOH4 minus 1 minus is there, and 4 H plus and 4 H plus 4 plus. Therefore, net charge here is plus 3 plus 3. Here no charge. You are adding 3 electrons on the product side and 3 electron minus 3, you will be adding this. Now, take this reaction 1 and 2 to find out the net reaction. The number of electrons on the reactant board should be totally consumed. In the the first reaction, 6 electrons are there. The second electrons, 3 electrons are present in the product side. Therefore, equation 1 is not necessary to multiply. You can keep it as such. And the equation 2 should be multiplied by 2 because 6 electrons. We are making this 3 plus into 6. We are multiplying with this. Now, after multiplying, add this to this side. 2 aluminium plus 8 H2O in giving 2 AlOH 4 minus plus 8 H plus 6 electron, and this 6 electron gets cancelled, and 2 Al plus NO2 minus plus water here in this side 8 In the other side, 2 water. Balance is how much? 7 Hg plus. Correct balance பண்ணிருக்கோமா? Is there any wrong in this? 4, 8, 2 in this side.
Sir, in oxidation side, it is necessary to add the 3 electrons.
Why do we have added 3 electrons?
Yes, sir.
Here, what is the net charge in the reactant side? What is the net charge on the product side without looking into these 3 electrons? The net charge is 0, aluminum 0 state, water 0 state, net charge is 0. Here, AlOH4 minus 1 minus is there, 4 plus. And what is the net charge? Plus 3 is there. Here, 0 charge is present, but in the product side, 0 plus 3 is there. You should balance the charges by adding the appropriate number of electrons to the appropriate side. Plus 3 should be made into 0. Therefore, you are adding 3 electrons. 3 minus.
Yes, sir. Yes, sir.
Therefore, I have added 3 electrons. In summing up the process, the 6 electron, the 3 here in the reactant side, 6 electrons are there. In the product side, 3 electrons are there. It should be equal in number during the summing up process. Therefore, the equation 2 is multiplied by 2. Therefore, the 6 electron, that 6 electron would be gets cancelled. Okay. Now, அப்படி பண்ணிட்டு இதை now multiply it by 2 பண்ணும்போது 2 aluminum, 8 H2O, 2 LOH4 and 8 H plus. Okay. Then we are summing up this process. என்ன போட்டிருக்கோம்? Plus water in the side. Now we are summing these 2 water here and 8 water, and therefore then remaining is the 6 water. And 7 H plus and 8 H plus is there. Therefore, there we will look into this NH3 aqueous plus 2 ALOH 4 times minus plus how many H plus? 1 H plus. Now, correct balance பண்ணிருக்கோமான்னு பாருங்க. How to change, look out, check this, 2 aluminum, 2 aluminum, 1 nitrogen, 1 nitrogen. How many oxygen? 8 oxygen, 4, we have done, and 2 into 4, 8 oxygen, 12 hydrogen, 3 hydrogen is already there, and 1 H plus, and 2 this one. 3, 8, 11, and 12. Okay, charge. Here 1 negative charge, here 2 minus and 1 plus, 1 negative charge. Therefore, we have balanced this equation. This is the net equation. But the reaction is taking place in alkaline medium, basic medium. The procedure we have adapted is a balance, how to balance a redox reaction taking place in acidic medium. I think follow the same procedure up to this net reaction. But one step is there, you have to convert the H plus ion. Instead of H plus ion, H plus ion should not be present. Only OH minus ion should be present either in the reactant side or in the product side. Therefore, next step is neutralize the H plus ion if present with the appropriate number of OH minus. How many H plus ions are present in the product side? Only one. Neutralize it with 1 OH minus. Okay? If you add one OH minus in the product side, you should also add one OH minus in the reactant side. If you add 4 OH minus in the reactant side, you should add 4 OH minus in the product side, and so on. Here only one H plus. After adding this, now the reaction is changed into 2Al plus NO2 minus plus OH minus plus 5H2O. Why I have changed into 5H2O? Tell me, anybody? Why I have changed into 5H2O? Tell me, anybody? And the neutralization, you are getting one water molecule. Here is 6 water molecule. Therefore, I have subtracted this. Then NH3 aqueous plus 2Al OH. 4 minus. Therefore, now what is your answer for the question? What is the question asked? What is the answer for your question? What is the answer for your question? How many OH groups are there in the balanced equation? Which is the correct answer?
One on reactant.
One on the reactant side. That's the correct answer. Another question that may be asked is how many water molecules should be present in the net reaction? 5 water molecules in the product side or reactant side. What answer is? Here, you may see that it is a long process. You may think it's a long time consuming process. If you work out it repeatedly, you will easily see that this is the method you can follow it. And now take down the question for exercising, balancing the redox reaction in basic medium. Complete the following redox reaction. Complete the following redox reaction in basic solution. In basic solution. Chromium hydroxide rise in solid state plus ClO minus in the aqueous state, giving CrO4 2 minus aqueous plus Cl2 gas. Cl2 gas. Here the question may be how many OH groups should be present in the net reaction and the total number of electrons involved in the process. How many electrons are involved in the process? Which is the oxidation species? Which is the reduction species? How many water molecules should be present in the net reaction? On which side? This type of questions may be asked. You work out and find out the answer for this, which is an oxidation species. If you see this, you can immediately see which is undergoing oxidation, which is undergoing reduction, which is a reducing species, which is the oxidizing species, and so on. For which you have to find out this is only chromium, how much is the oxidation state, chromium, what is the oxidation state, chlorine, what is the oxidation state, what is the oxidation state of chlorine, the product side. Looking these two pairs, you can see which is the oxidizing agent, which is the reducing agent. How many electrons are involved in the process. And then you can easily, in one-step process, you can easily, not here one step, but in two-step. In acidic medium means without separating into the two-half reaction. If you are exercising the ground, you will keep the reaction in one-step process and you can balance the equation. After balancing this, it will be ending with the H plus ion, then convert into OH minus ion. Is it possible to keep it in the in one-step process? Yes, it is possible. For which the same procedure, balance the species first, then balance the oxygen in terms of water molecules to the appropriate side, without separating these. Then next step is add hydrogen in terms of H2 plus ion. Finally, balance the charge. நீங்க பார்த்தீங்கன்னால பேலன்ஸ் ஆகியே தான் இருக்கும் சார்ஜ். எலக்ட்ரானே போட வேண்டி இருக்காது. Now you will be end up with H plus ion, then add OH. This is second state. Therefore, I have taught you the basics of it step by step. But after well versed with this, it is not necessary to split the given unbalanced equation into two. You can easily keep it in a one step. You can convert it into a balanced equation for acidic medium. Then add OH, convert it into the net reaction taking place in the basic medium. All this is possible. Only work out the problems because so far I think you are not working out this type of problem. Therefore, it is necessary. It's a mandatory. With this introduction about this electrochemical reaction, we are entering into the process of spontaneous electrochemical reaction. Spontaneous electrochemical reactions, we are entering into the voltaic cells. In the voltaic cells, electrons are immediately automatically transferring from one species to another species. From which species to which species the electron transfer would be taking place? This can be theoretically answered after seeing the redox potential. After seeing the redox potential, you will be well versed giving from of these two couple of electrodes, from which electrode to which electrode the electron would be transferred, and what would be the voltage of the cell constructed by using these two one. And from the voltage, you can calculate what is the free energy change, what is the work done by the voltaic cell, what is the equilibrium constant for the reaction, what would be the heat involved in the process, what is the entropy change, and all other thermodynamic parameters can be easily calculated. These are the applications of the electrode potential. Now we are entering into the voltaic cell, and the voltaic cell is constructed using a spontaneous redox reaction or electrochemical reactions. Electrochemical reactions is only made up of the oxidation reduction reaction. And if you want to carry out a redox reaction, you can do it in one way. What is the way? But that way is not useful for us. You are changing the way in a different manner. And for a simplicity, what is a redox reaction? It will be a spontaneous redox reaction which will be taking place. And we normally write it as zinc solid, copper 2 plus aqueous, giving zinc aqueous plus copper solid. What is the net reaction? Here, which species undergoing oxidation? You can easily see this. Zinc in the 0 state is converted as zinc in the 2 plus state. Therefore, zinc is undergoing oxidation. It gives out the electron. Therefore, zinc is the reducing agent. Here, which is oxidation agent? The copper 2 plus, which is accepting electron. Copper 2 plus is accepting the electron, and it is converted into copper. Therefore, it is undergoing a reduction. This species is undergoing a reduction, and it is called the oxidizing agent. Copper 2 plus is the oxidizing agent. How many electrons are involved in the process? 2 electrons are net electrons involved in the 2 electron process. It's a 2 electron electrochemical process. Here, what are the reactants required? A zinc, solid zinc, and a copper 2 plus aqueous solution. And I am taking copper aqueous, copper chloride or copper nitrate or whatever may be the soluble copper. Here I am taking copper sulfate solution. Okay, now I am placing a zinc rod in it. This is a zinc rod. Okay, whether reaction is taking place or not. According to this, it's a spontaneous reaction. Definitely it will be taking place. Electron is furnished by zinc. Zinc is the oxidation half reaction. We call this oxidation half reaction. Zinc is furnishing zinc 2 plus and 2 electron. And the zinc 2 electrons are present here in the solution. And zinc 2 plus is also formed in the solution. The 2 electrons will be taken up by the copper ion present in this, and it is converted into copper solid. And the copper solid would be looking like the brown in color. The copper sulfate solution concentration is going on decreasing. Therefore, because copper 2 plus ion is converted into copper sulfide and copper solid, therefore the red precipitate is going on increasing. And the rod, zinc rod, weight is going on decreasing. Why zinc rod weight is going on decreasing? Because it is converted into zinc 2 plus and is going into the solution. Therefore, here zinc rod is losing the weight and so on. Here, whether the electron is said to be transferred or not from where to where, zinc is transferring electron to copper 2 pieces. Therefore, copper 2 plus is converted to copper 6. And we can visually see the color change. Therefore, we can come to the conclusion reactions are taking place, electrons are said to be transferred. And using this reaction, no net applications are possible in our case. We want to see the flow of electron from zinc to copper 2 plus solution. How to design the apparatus so that the electron is flowing from zinc to copper 2 plus, for which what I have drawn this diagram is not applicable. And scientists found out finally they make the cell into 2 half shells. They want to take the reactants, both the reactants zinc and copper 2 plus in one and the same shell. They take one reactant in one shell and another reactant in the another shell. This is the zinc rod in this, and this is the copper sulfate solution or copper 2 plus solution. Okay. And how to send the electron from zinc to the copper sulfate solution? You know, for conducting the electrons, some solid conductors are necessary. Therefore, here also there one conductor should be present. Which conductor should be used as an electrode? And what is the aqueous ion? What is the metal aqueous ion? Metal ion present there. If a metal solid is available, make use of that solid as the conductor or electrode. If you take the calcium chloride solution, if calcium solid is available, you can make use of the calcium rod as the electrode. If you use chromium hydroxide solution, chromium metal is not available. In such cases, if no suitable metal, solid metal is available, you can make use of platinum or graphite as the electrical contact. They are all called the conductors. For example, H plus ion. Here hydrogen should be passed, and here hydrogen is not present in a solid state. No solid electrode is available. In such cases, whenever you pass gases, and you should use platinum as the electrode. If iodine means here, solid is there, but it is a non-conductor because you know electrons to be conducted, therefore metal solids are able to conducting the electron. Therefore, a solid metal should be there. Iodine is a non-conductor. Therefore, though it is a solid, it cannot be used as a electrical conduct electrodes. In such cases, either platinum or graphite should be added as the conduct, electrical conduct. Therefore, here copper sulfate, you can use the copper rod as the conduct. And here, the solution should be there, in which in the reactant side, here zinc should be converted into zinc 2 plus. Therefore, here also, you have to take water instead of water. You are using zinc sulfate aqueous solution is there. Then only zinc is converted into zinc 2 plus and it is passing into the solution. Instead of zinc 2 plus, we are adding zinc rod. If you are using zinc 2 plus ion is used as you want. Now, from which electrode to which electrode, according to this equation, the electron is said to be transferred from zinc electrode. Therefore, make a electrical contact using a copper wire, etc. Now, from this copper wire and there you are passing the electrons. Now you are transferring electrons from the zinc to the copper ions. And this electrode, from which electron is passing, is generally called as the anode. Or anode is also said to be the electrode which is undergoing oxidation, because oxidation takes place and the electrons are released and the electron is transferred to the another one, therefore anode. And this electrode, we call it as the negative electrode. What is the charge over this anode? Negative charge. Just like anion is having negative charge in the electrochemical shell, anode is having negative charge. But in the reverse process, electrolytic cell, anode would be having the positive charge. That we study while studying the electrolytic cells. And what about the charge over this copper electrode? Is a positive, because relatively it is accepting the electron and it is a positive charge. Therefore, for producing electricity, we are in need of two electrodes. One is positive electrode and a negative electrode. Now, whether reaction is taking place or not, here the reaction would not be taking place. Why? We are connecting the zinc rod and the copper rod. Zinc is going to furnish a zinc ion and the electrons are released and the electrons are going from the zinc rod through this external wire. It is going to the copper electrode. And the movement of electron can be demonstrated by including a voltmeter in the circuit. Because the passage of current is, we call it as the electricity. Electricity is nothing but the movement of electron. Therefore, electrons are moving from anode to cathode. But initially, no significant movement of electron is there. Why? Because any circuit would be, any electricity would be passed only if the circuit is completed. Here we have not completed the circuit. How it is, in this way it is present here and we complete up to this. Completion means here to here. There would be a completion. There should be a joining between these things. Why it should be joined? Without joining this, no current is passed. Why? Because in this process, the zinc is going on increasing. Zinc is going on increasing the concentration, zinc 2 plus and 2 electron. The 2 electrons would be moved to the next cathode compartment, but the zinc ion would be replaced in the anode compartment. The anode cell, it would be remaining. Therefore, in this already zinc sulfate is present. A neutral charged species are there. That is zinc ion and sulfate ion, equal numbers are present. when electrons are releasing, which is going to be added to this. Zinc ion alone is going to be added. The negative charge 2 electrons are transferred to this. Therefore, the imbalance between cation and the anion. Imbalance between the cation and the anion. So is the case here also. When electrons are reaching in the copper cathodic compartment, we call it the cathode half shell or cathodic compartment, we call it as. The copper ion will take the electron and it is deposited as copper on the copper electrode deposited. Therefore, as the process is going on, initially copper 2 plus and sulfate ions are present in equal amount, equal charge. Electroneutrality is there. As copper ions are going on, depositing over the electrode, the concentration of copper 2 plus ion is decreased, whereas the concentration of the sulfate 2 ion. Sulfate 2 ion is remaining the same, but copper 2 plus ion is remaining. Therefore, net charge over the cathodic compound is a negative charge is higher in anode compartment. Positive charge will be higher. Due to this imbalancing in these two compartments, they prevent the passage of electricity. Therefore, these two ions, the negative charge, the sulfate ion which is excess in this, allowed to move to the positive charge present in the anodic compartment. Therefore, the anion should be allowed to move in this, and the cation should be allowed to move from anode to cathode. It should be allowed to move this way and that way. If you allow this passage, then the electric circuit is completed. Then there will be a electron is moving and the imbalanced charge will be balanced by movement of the anion from the cathode to anode compartment and cation from the anode to cathode compartment. These are all taking place simultaneously. How to make these ions to move on either side, for which in practical purpose we are making use of the salt bridge. The salt bridge would be either U-shaped one or it is a inverted type shape, and which consists of electrolyte. The electrolyte in the form of paste or gel, and which is normally used in the alkaline salt, potassium chloride, potassium nitrate, ammonium nitrate. So generally, the sodium nitrate would not be used because of its deliquescent nature, or ammonium chloride. And what is the important condition for electrolyte to be used in the salt bridge? In the salt bridge, it should not be reacting with either of the solution. Either of the solution means either in the cathode compartment or anode compartment, whatever may be the ions present, it should not undergo reaction with that ions. That's the essential condition. For example, in one compartment, we have taken the silver nitrate. In that place, shall we use potassium chloride or ammonium chloride and present this salt bridge? You should not use, because the chloride ion moving towards the silver nitrate would react to Kinsler chloride precipitate. Therefore, that's an important condition. Is one condition that ions, either the cation or the anion, should not react with the cations, anions, or the electrodes present in any compartment. Any compartment means either in the cathodic compartment or in the anodic compartment. To all the species, it should be a neutral one. Neutral in the sense, it should not undergo reaction. Second thing, what is the rate of movement of the cation to the cathode compartment? And what about the rate of movement of the anion towards the anode compartment? It should be more or less the same. Otherwise, then also the stoppage of the electricity is possible. Therefore, if These two categories conditions are normally fulfilled by this one, and completely fulfilled by this potassium nitrate, ammonium nitrate, and the ammonium chloride and the sodium potassium chloride. Here, whenever silver nitrate is used, you should not use this potassium chloride, ammonium chloride salt bridge. Therefore, you might have seen the salt bridge, and instead of writing this cathodic compartment diagrammatically, we are representing in the short form of this representation. Either we represent is zinc bar, zinc sulfate, and the salt bridge is represented by a double bar, and the copper sulfate bar copper. The copper is a solid. Here the concentration should be mentioned. Here also the concentration should be mentioned, and it is a solid, and it is an electrical contact. Here, what does it mean? It is a common practice to write down the anode in the left hand side and the cathode in the right hand side. How to remember this? There is also a mnemonic for the low. What is low? Expand this one, anybody? Low. A mnemonic. Anybody expand this?
Loss of electron, oxidation, anode, and negative.
Left side. When you write this cell in terms of representation, instead of drawing diagram, you are representing this. The left side, that is zinc bar, zinc sulfate, is an oxidative one, A for anode, and it is bearing negative charge. Low. Left oxidative anode bearing negative charge. If you keep this in your mind, what is this in the cathode? You can see the right hand side reduction, cathode positive side. Therefore, it is sufficient to keep it in your memory. The load, it is customary to write down. Here, it is a negative electrode. This is positive electrode. Negative electrode means electron is passing from this to this. Okay. And here, in which compartment there is a loss in the compartment there is a loss in the weight of the electrodes. Which compartment there is a gain in the weight of the electrodes? Tell me, anybody? In which compartment there is a loss in the weight of the electron? Which compartment there is a gain in the weight of the electrode? Nobody? Which compartment? Anode compartment there is a loss of electrode. And the cathode compartment here, zinc is dissolving into zinc 2 plus ions. Therefore, zinc weight is going on decreasing. In the cathode, copper 2 plus ion is converted into copper solid deposited on copper electrode. Therefore, its weight is increasing. Whenever during this electrochemical process or voltaic process, there is a weight loss in the electrode. Here in this side, you can make use of the graphite or platinum. Here the platinum is used in the right hand side, is electrical contact through which electrons are received, and it will be given to the copper 2 plus ion. That the copper 2 plus ion will be converted into copper and it will be deposited on the bottom of this. It would not be adhering on the platinum itself. Therefore, the weight of the platinum would be remaining as such. Let us assume. Then such electrodes we call it as the inactive electrode. Such electrode we call it as the inactive electrode. So then in this voltaic cell, whether anion cation movement would be there or not. Cation movement would be there or not. Hello? Any voltaic cell, definitely there will be an anion cation movement through what? Through the salt bridge. And which ion would be moving towards this, which ion will be moving towards, கொஞ்ச நேரத்துக்கு முன்னால தான் சொன்னல, cations towards the cathode compartment. எதுல இருந்து? From anode to cathode compartment. And anions from anode compartment, cathode compartment to anode. Or keep it in mind like this. Cations to cathode, anions to the anode compartment. There is a traveling would be there through the salt bridge. Okay, the salt bridge is represented by the double arrow bar, or it can also be written as zinc bar, zinc 2+. Instead of indicating the counter ion, this it can be also written as like this. You should mention the concentration here, bar copper. Or in some other book, they would write, instead of single bar, they would call the semicolon and zinc 2+, C1, double bar, copper 2+ C2, semicolon copper. Or instead of zinc 2+, they may also write the counter ion including, and zinc colon and zinc 2+. These are some of the ways by which the voltaic cells are represented. Okay. And is the only way you are transferring cation to anion on either side through the salt bridge? There is another device called the porous part or porous plate or porous glass. Porous part or porous glass. That is called as, for example, the same thing. You might have studied the porous part. Nundulai manbandam Tamil solluvaanga. If you are using the porous part through which the cation and anions are passing through this, now we will representing it by a single line and copper sulfate or copper solid. In some cases, instead of writing a single line, they use this breaking line indicating there is a porous passage for this one. Therefore, whenever a single line is used, you will remember that porous plate or porous part is used. These two are separating this. This can be diagrammatically represented like this. This porous part can be represented like this. This is a single part separated by the porous part. Therefore, these two electrolytes are kept separate from each other. Whenever electricity is passed or electron is moved, the electricity is completed, and the sulfate ion from this to this compartment, zinc ion from this to zinc 2+. Here the sulfate ion moving from this one, and from this to this electrons are moving, and the zinc rod there is a loss in weight, and the copper there is a gain in weight. Whenever there is a loss or gain in weight, they are said to be active electrode, and there is no change in the mass of this before and after the process. They will be called as the inactive electrode. Now we understand how we are making use of this. If you understand this one, and now I am going to give you a question, and by making use of this question, you are able to give which species is present in the cathodic compartment, which species in the anodic compartment, how many electrons are taking place in this one, and which rod is used as the anode rod, and which rod as the cathode rod, and all the things you have to tell. If you are able to understand this concept so far discussed, take down this question. Describe the voltaic cell generating current. Voltaic cell is sufficient because a voltaic cell is one which is from which electricity is produced. Generating current due to the following. Spontaneous redox reaction. Due to the redox reaction is sufficient because only from the spontaneous reaction we are able to generate electricity. Take down this Cr2O7 2 minus plus 14H plus aqueous, here also aqueous, plus 6I minus aqueous, giving 2Cr3 plus aqueous plus 3I2 solid plus 7H2O liquid. This is the net reaction, cell reaction. The oxidative half reaction and the reductive half reaction. It's a net cell reaction. Indicate the electrode use. The reaction occurring at each electrode. What a reaction that is taking place to each electrode. The direction of migration of the electron. The direction of ion migration. The sign of the electrode. Whether it's the active electrode or inactive electrode. Whether it is active electrode or inactive electrode. All these you have to give answer if you understand this concept. Yes, it is possible. How to give the answer for this? First, you find out here which is undergoing reduction. Oxidation species should be low, left anode, negative அப்படின்னு படிச்சிருக்கோம். Oxidation எதுக்கு போகுது? Find out which is undergoing oxidation. That is anodes. Anode, whether that is having a suitable solid metal is there. If no solid material is there, then make use of platinum or graphite electrode. Okay. Then similarly, if you one species is undergoing oxidation, then the other species should be definitely reduction. The cathode compartment and which solution should be present in cathode compartment. You should be able to this. First, I will draw the diagram. One compartment, this is another compartment. And we generally write it is the anode compartment and this is the cathode compartment. Here we are using one electrode, here we are using another electrode. Here one aqueous solution would be there, here another aqueous solution would be there. If these two are well separated from this, we can make use of a salt bridge. And these are externally, circuit is completed. You can make use of an voltmeter or voltmeter there. And now our is describe this voltaic cell. How to describe this voltaic cell? Here anode, which reaction is taking place? Oxidation. And cathode, reduction. Therefore, first identify which is undergoing oxidation, which is undergoing reduction. Here you have to consider the species chromium and iodine, because these two species are there. From the reactant side and product side, you will immediately tell which is undergoing oxidation, which is undergoing reduction. Take the simplest case, iodine. Iodide is having one negative charge, therefore what is the oxidation number of iodine? In the iodide case, it is -1. In the reactant side, iodine, this iodine is present as 3I2. Iodine is a element, therefore its oxidation number is 0. Whenever the oxidation number is increasing in the positive direction, it is said to be oxidation. Therefore, converting I -2, 3I2. What is the name of this reaction? Anybody tell me? Here this is -1, this is 0. What is the name you are going to give? Tell me. Oxidation reaction. There is an oxidation reaction. I have told you that Whenever it is increasing the positive direction, the oxidation number is increasing towards the positive. That is -120, increasing the positive direction, oxidation. If in the other way, you call it as a reduction. Therefore, oxidation takes. Oxidative reactions are taking place in which compartment? Anode compartment. Therefore, anode oxidation load we have given. Therefore, here, which reaction is taking place? 6I minus is converted into 3I2. How many electrons are consumed or released? So, by making use of this, how many electrons are consumed or released? Oxidation nale electron endha pakkam varanumnu sollirken. Endha side varanum oxidation nale
Product side.
Product side. How many electrons should be there in the product side? 6I minus giving 3I2 plus 6 electrons. Therefore, total number of electrons involved in the process is 6 electrons. Problem solved. One எடுத்தோனே தெரிஞ்சு போச்சு. Therefore, another thing, the cathode என்னவாத்தான் இருக்கும்? Production CR2, because other species present is this one. CR2O7 is converted into 2CR3 plus. இங்க electron எத்தனை consume பண்ணி தான் இருக்கும்? 6 electrons are consumed. Now you have written which is the anode, which is the cathode. Here iodine non-metal is present. Therefore, definitely no solid electrical contact is available. Therefore, here the electrical contact, you should make use of which electrode? Tell me.
Platinum.
Platinum. In the other side, chromium metal is not also available. Pure metal is also not available. Here you should make use of, once again, platinum. And now, first question is answered. Indicate the electrodes used. Platinum electrodes are used in both the cases. Then, reaction occurring at each electrode, we have already given. Reaction occurring at each electrode. That is, you can add plus 6 electron. Here you can add plus 6 electron in the reactant side. The next question is the direction of electron migration. What is the direction of electron migration? From the platinum, what is the net charge over this anode? Take once again the multiple choice question, but do not the CSAR examination is a basic level question. The following two half reactions occur in a volcanic state. Take down this nickel solid giving nickel 2 plus aqueous plus 2 electron. Electrode nickel metal is available, therefore electrode use nickel. Then 2 electron plus copper 2 plus giving copper solid. Electrode used is copper because copper solid is also available. The electrode is losing the mass and cations from the salt bridge are flowing into the half shell. Sec B, the electrode is anga losing போட்டீங்களா அங்க என்ன போட்டுக்கோங்க அடுத்தது gaining அப்படினு போட்டு மீதி எல்லாம் டிட்டோவா போட்டுருங்க. Gaining the mass and cations move from the salt bridge or flowing into the half shell. அடுத்தது C, the electrode is losing the mass போட்டு ஆனா அடுத்ததுல எப்படி எழுதணும் அங்க cations from the salt bridge எழுதுறதுக்கு பதிலா and anions from the salt bridge are flowing into the half shell. D option எப்படி எழுதுறதுன்னு சொல்லுங்க, நீங்களே இந்த டிசைனை முடிங்க பார்க்கலாம். இதுதான் இருக்கும் அப்படின்னு சொல்லுங்க பார்க்கலாம். Anybody? The electrode is
Retaining the mass.
okay, and
Anion moment. Anion moment.
anion from, yes, you are right. Good. And anion from the salt bridge are flowing into the half shell. இப்ப நம்ம சொல்லி கொடுத்ததுல ஒரு பார்ட்டை மட்டும் கேட்கறாங்க. என்ன சொல்லி கொடுத்தோம், ஏது சொல்லி கொடுத்தோம்? வெறும் காப்பர் எலக்ட்ரோட எடுத்துக்கிட்டு பேசு அப்படின்னு சொல்றாங்க. அந்த ஈக்குவேஷனை வச்சு பார்த்தாலே உங்களுக்கு தெரியும். எலக்ட்ரோடு காப்பரா, காப்பர் சாலிட் உண்டாகுதான். அதான் யார் மேலதான் போய் உட்காருவா? It will be resting on the copper electrode. Therefore, there is a gaining. இன்னொன்னு ஆனியான்ஸ் மூவ் ஆகுது இதுக்குள்ள அப்படின்னு சொல்றாங்க. எது கரெக்டுப்பா? Which one is correct? Option B. Option B is the correct one. Option B. That is cations to the cathode. Okay. சரி, the next topic. These are the basic things. அதான் போறேன். நீங்க படிச்சிருப்பீங்க நிறைய பேர் தெரியாமலும் இருக்கலாம். whatever may be the case. இப்ப இருந்து நம்ம சொல்ல போறதுதான் அநேகமா ப்ராப்ளம்ஸ். Questions should be arised from the following section. But this so far discussed is very, very important for following the electrochemistry. Next is the electrode potential. Electrode potential. What do you mean by electrode potential? How it arises? And what are their applications? And whenever any metal or non-metal, whatever may be, is then dissolved in its salt solution. Zinc is dissolved in zinc sulfate, copper in copper sulfate. Therefore, this is the metal. It is dissolved in a aqueous solution, Mn+. Depending upon the nature of the metal, or two phenomena of either one of the two phenomena are possible. One is the metal has the more tendency to form the cations and forming electrons. That is, metal has the tendency to undergo oxidation. This process we call it as the de-electronation. இதுக்கு இன்னொரு பேர் என்ன வச்சிருக்காங்க? De-electronation. The electron is removed. De-electronation. Or another thing is that the metal ion is having the tendency to undergo reduction. Mn plus n number of electron giving M. This we call it as the that is a de-electronation. இது வந்து electronation. அதாவது reduction சொல்லாம we call it as the electronation. அது oxidation சொல்லாம de-electronation. Electron. Any metal or anything when you dissolve or when you place in its aqueous salt solution, either of these two would be predominant. ரெண்டுமே ஈக்குவலா இருக்கிறது. No chances are there. Either the de-electronation or the electronation would be the predominant. And now we will see three cases are arising. One case, the de-electronation is predominant, or another case, electronation is predominant. The third case is if these two are equal, what happened through the system? All we are going to see this one. And now first we take de-electronation is predominant. That is the species, the metal is having the tendency to undergo oxidation. It is predominant to the electronation process. What happened is, now it is dissolved in this. This is the material is, and the surface of this surface of this metal is smeared with this electron negative charge. And the positive charge, the metal ion solute we have dissolved and would be present like this. And a electrical double layer is produced. Whenever two layers are produced, the positive and negative charges are there. Then electrical double layer, we call it as some potential would be developed at the junction. Positive and negative charge the junction, some potential is developed. That potential we call it due to the electrostatic attraction, some potential will be developed. That potential we call it as the oxidation potential. Here we call it as the oxidation potential. Because oxidation is taking place, oxidation potential, and it is represented by OP or E of OX, epsilon, not E, epsilon of OX. The epsilon is small and the small script is reserved for representing the electrode potential. And capital script E is represented for the cell voltage, E ox, or epsilon of M bar Mn to Mn plus. That is the reaction process would be written, or we name it as in terms of ox, or it is OP. This may be the way of representing the oxidation potential. This is due to the double layer potential, electrical double layer potential. What happened when the electronation is predominant? Then the de-electronation, that is reduction is predominant. Here also a double layer would be obtained. But this double layer is different from the other. Here it is positive charge, zinc 2 plus is mirrored on this. And the electron coming from other side would be present like this. A small amount would be present like this. Because predominant is the Mn plus is undergoing reduction is the predominant species, which would be near the electrode, and the other species would be present in the other side. Here also electrical double layer. And in this electrical double layer, we call it as the junction potential, we call it as the reduction potential. And the reduction potential is represented as Rp, or epsilon, or red, or epsilon, Mn plus bar M. This way we are writing this one. And there is a sign convention. This potential and that potential. For any metal, the oxidation potential would be equal to its reduction potential, but sign is change. For example, zinc bar zinc 2 plus, as we have written, it is oxidation potential. If the value is 0.76 volt, then what about its reduction potential value? That is zinc bar by zinc. It is the same magnitude, 0.76 volt, but sign is change. Which should be given a positive value, which should be given a negative value. According to IUPAC, the positive value is given if the reaction involves a reduction when connected to the standard hydrogen electrode sheet. What is the standard hydrogen electrode? Or simply, we can convert this IUPAC recommendation in other way. The positive value is given for the species undergoing a reduction of And with respect to SKG, what is standard hydrogen electrode அப்படிங்கிறத நான் தர சொல்றேன். And a negative potential for the those species is undergoing oxidation. Which is undergoing oxidation with respect to these metals are undergoing oxidation. And this is undergoing oxidation. It should be given a negative value and it is given a positive value அப்படிங்கிறது IUPAC recommendation. But there are two sign convention of the electrode potential. Of these two, we are following only one. One is called the European Convention. Another is called American Convention. The sign notation. American Convention. The European Convention, whether you write this epsilon is Zn bar Zn2 plus or epsilon Zn2 plus bar Zn, எப்படி எழுதுறாலும் சரி, European call this as the electrode potential only. They want to say oxidation potential or reduction potential. They won't call it as separately oxidation and reduction potential. They call it as the electrode potential. Then this electrode potential, they call it as, we call it the invariant quantity. The oxidation potential, they won't call it separately as the oxidation potential or reduction potential. They call it the electrode potential, which is equal to the reduction potential only. The reduction potential only. For example, the metals are all having the reduction potentials negative. Then I'm sorry, it is இப்படி எழுதினாலும் சரி, Zn2 plus for zinc எழுதினாலும் சரி, in the European Convention, it indicates only the reduction potential. The way you write it, unless they would call this electrode potential only. But American Convention is, they call the potential in two ways. If oxidation occurs, they call it as the oxidation potential. And if a reduction occurs, then we call it as a reduction potential. And the sign convention is epsilon Zn bar Zn2 plus and epsilon Zn2 plus bar Zn. In American Convention, both of them having same value, but the sign is different. Reduction potential, this is called the reduction potential. Here the value is minus, and the oxidation potential, the value is plus. And for our purpose, for calculating the EMF of a cell, etc., we are going to follow the American Convention, not the European Convention. But if you come across some authors, foreign authors book, they belong to European country, they will simply call it as the electrode potential. They will write either for the oxidation symbol or reduction symbol, but they will give only one type of the value. They refer that it is a reduction potential. If you want to change it to oxidation potential, simply change the sign. If a reduction potential of is given as 0.344, then its oxidation minus 4. Similarly, just change this. But in American Convention, they will make use of these two conventions separately. Therefore, electrode potential is a bivariant quantity in American Convention. It is a bivariant quantity in American Convention. That's the difference. Physicists and the physical chemists usually follow the American Convention because it is very easy for doing the problems. Okay, and the other thing, this sign convention, I think it is stop at this one. Next day, you are going to see what is standard electrode potential. Now, electrode potential means in American Convention, you should ask Sir, whether you are referring to the oxidation potential or reduction potential. If I told the electrode potential according to European, we should not ask question because it's always reduction potential. But here we are going to follow American convention, therefore don't follow the European convention. And what is the standard electrode potential? What would be the what would be the values electrode potential, standard electrode potential for each electrodes available in the world, and what is the periodicity in the electrode potential? Then we are going to see the application of this electrode potential in the next session. Okay, thank you very much. Until then, have a nice day.